Hi, this is the second lesson on topic 14, and in this lesson, we're going to talk about density. Here we have two balls, a bowling ball on the left-hand side and a beach ball on the right-hand side. Both are the same size, meaning they both have the same volume. Having said that, though they have the same volume, they have a different density. The bowling ball we have here is far more dense than the beach ball. For example, if you were to drop each of these in water, the bowling ball would sink, but the beach ball would remain floating on the surface. That's because the bowling ball has far more mass inside it, even though they are the same size. That means its density is far greater. Density is how much matter or mass there is in a given space or volume. This is related to the distance between particles. If the particles are more closely packed together, they are considered more dense. Based on this definition, the density of an object can be calculated using this equation. Density is equal to mass divided by volume, where density can be given by the symbol ρ. Mass is given by m, and volume is given by v. The unit of mass, as we know, is kilogram. The unit of volume is meter cubed, and therefore the unit of density is kilogram per meter cubed. Let's try applying this equation to some questions. So, in this question, a block of aluminium has a mass of 500 kilograms and a volume of 25 meter cubed. What is its density? The first thing we do when we have a question like this is to write the equation. Next, we're going to substitute from the question into our equation. And as we can see here, our mass is equal to 500 kilograms and our volume is equal to 25 meter cubed. Next, we're going to enter this into our calculator. And we can find that the density of the aluminium block is 20 kilogram per meter cubed. And that's it. Let's try another one. In this case, pause the video and have a go. Okay, hopefully you've attempted this question now. Now let's go through it together. The density of copper is 8,960 kilogram per meter cubed. What volume of copper has a mass of 5 tons? So the first step, as we know, is to write the equation. Next, we're going to substitute from our question into this equation. Density is 8,960 kilogram per meter cubed. Our mass is 5 tons. And our volume is unknown. We'll leave that as V. Now, our mass is in tons, but as we spoke about earlier, our mass should be in kilograms. So we need to convert 5 tons into kilograms. To do that, we're going to multiply by 1,000. So now we're left with 8,960 kilogram per meter cubed is equal to 5,000 kilograms divided by a certain volume. Now to solve this, we're going to multiply by volume on both sides, and we're going to divide by 8,960 on both sides. This gives us 5,000 kilograms divided by 8,960 kilogram per meter cubed. Now we just enter this into our calculator and find the answer. Our answer is 0.558 meter cubed. Let's try another. Pause the video and have a go. Now let's go through this question together. A swimming pool has 2,500 meter cube of water in it. If the density of water is 1,000 kilogram per meter cubed, what mass of water is in the pool? So, we're going to follow the exact same process, and the first thing we're going to do is write the equation. Next, we're going to substitute directly from our question into this equation. And we can see that our density is 1,000 kilogram per meter cubed. Our mass is unknown, so we'll leave that as an m. And our volume is 2,500 meter cubed. Now to solve this, we need to multiply both sides of our equation by 2,500 meter cubed. Now we simply need to enter this into our calculator and find the result. This gives us an answer of 2.5 million kilograms, or 2,500,000 kilograms. Hopefully you've got that. Now it's time to move on to the next part of this lesson. And this is measuring the density of liquids and solids. Now it's important to know how to measure the density of both a solid and a liquid. But let's consider liquids first. As we just saw, the equation for density factors in both mass and volume. So we need to take measurements of both mass and volume when measuring density. So for a liquid, the first thing we're going to do is we're going to place a measuring cylinder on a balance like this. Next, we're going to press the 0 button, and this allows us to only measure the mass of the liquid inside, but not the mass of the measuring cylinder. Next, we're going to add the liquid, like so. So we can see the mass directly from the balance here, and we can see the volume of the liquid from the graduated column on this measuring cylinder. Because we've got mass and we've got volume, we can easily find the density. Now there are two ways to measure the density of a solid, and both are based on the Archimedes principle. In method A, which we can see here, we place a solid in a liquid of a certain volume. And as the solid is placed in the liquid, a certain volume of the liquid is displaced. We can see that here. Initially, the liquid had a volume of 150 milliliters. However, afterwards, the measuring cylinder shows a reading of 180 milliliters. This additional 30 milliliters is due to the solid in this liquid. So the volume of this solid is equal to 30 milliliters. That is the volume of the solid itself. Combining this with the mass of the solid will allow us to calculate the density. Let's take a look at method B. This is called a eureka can. Step 1 is to measure the mass of the solid. Next, we are going to fill the eureka can right up to the spout, and any excess water will drip out into the measuring cylinder. As a result of that, the water will be just up to the spout so that none can flow over. After placing the solid into the measuring cylinder, some water will certainly be displaced and flow out into the measuring cylinder. By recording this volume of water, we can calculate the volume and we can identify the volume of the solid. Based on that, we can calculate its density. And that's it. I hope you found this lesson on density useful. If you have any questions, please do ask.